So now since we have done with the pre-processing of both the categorical and the text features in the previous reference notebook, so as a result we are left out only with the clean text, or you can say the data in a clean form after removing all the extra symbols or the unnecessary words that are no longer helpful for us in the featureization process, right? So now coming to the third reference notebook, we will see how to perform the vectorization on the features, or you can say how to convert the features into numerical form. Fine. So now let's get started. So here you can observe as the first step we are importing some of the libraries here. So you already know most of them and the rest we will see in a meanwhile. Okay. So now let's see loading the data set here. So now using pt.read_csv, we are loading the file that is preprocessed_data.csv, and this file is having the feature values that contain the data in the preprocessed form. And also you can find this file in the zip folder provided to you. So now you can check out that we are having the feature value that contain the data in the preprocessed form, right? And also we are only working with the 5000 number of rows here, or you can say we have taken only 5k data points. So one point I forgot to mention in the second reference notebook here, that whatever the pre-processing we have done in this notebook is also performed on only 5000 data points. Why? Because our main motto is to give you the brief overview about the concepts that are needed in general in order to solve the machine learning problem. But if you want, then you can run the same code with a larger number of data points. So instead of 5000 here, you just replace this number with, let's say, the 50k points. Fine. But we just limited ourselves to only 5000 points in all our reference notebook. Clear? So now let's see how to vectorize the text features here. And the first method we are applying is the bag of words. And also since we know that we are having the two text features in the data set to deal with, the first one is the project title and the second one is the project essay. So now let's see how to perform the vectorization on the feature essay here. So for that, first we are taking the feature essay from the data set and storing the values in the variable preprocessed_essays. So now for applying the bag of words, we have to first initialize the count vectorizer that we have taken from the scikit-learn library, and within that we initialize the parameter min_df is equal to 10. So with this parameter we are considering only the words that have appeared in at least 10 documents, or you can say in 10 rows or 10 projects. So you can think this value as a threshold, and we are simply ignoring all the words that are below this threshold value. Fine. And now we are doing vectorizer.fit_transform on the variable preprocessed_essays that we initialized here, right? So what we are basically doing with this second line, you can see here that first we try to build the vocabulary based on the unique words that are present in preprocessed_essays and also that are above this threshold. So let's say we found D such unique words. Fine. So now in the second step what we are doing, that we are replacing each word by its count value. For example, let's say for the first row in the preprocessed essay, if the word W1 is present only one time, so we are replacing this word by its count, that is 1. And let's say the word W2 is not present in the first row of the preprocessed essay, so we are replacing it by 0, and so on. And also let's say if the word WD is present 2 times in the first row, so we are replacing this word by the number 2. So this is basically how the bag of word algorithm actually works, that you already know. So basically these two tasks are performed by this single line with the function fit_transform here. Clear? And also you can see the shape of the sparse metric after the bag of words revectorization for the feature essay, that we are having the 5000 number of rows and we are having this much number of columns, or you can say this much number of unique words. Clear? So just like what we did for the essay here, you can perform or run the same code with the next feature, that is title. So as a result, you will see the bag of word representation for the title feature as well. Okay. So now let's see the another method, that is TF-IDF vectorizer. So here also first we are initializing, importing the TF-IDF vectorizer from the scikit-learn library, and now instead of initializing the count vectorizer, we are initializing the TF-IDF vectorizer with the same parameter, that is min_df is equal to 10. And here also using vectorizer.fit_transform, we are passing it to the preprocessed_ss. So here again first we build a vocabulary based on the unique words that are present in the preprocessed_ss. And now in the second step, instead of replacing a word by its count value, we are replacing by its TF-IDF value, right? So now you can see here also the shape of the matrix after TF-IDF vectorization for the feature SA, that we are having the 5000 number of rows and this much number of features. So now you can simply observe that with the help of the libraries, we can easily switch from the one method to the another method, right? So now let's move on to the next method here. So the next method we are applying is the average word to vec. For that, here we are using the pre-trained model, that is a globe vector that is already trained on the large corpus of the data. So basically we are here simply loading it, that is a globe_vectors, and storing it in a variable globe_words. Fine. So basically this variable contains the word embedding in the vector form for the different words, right? So now let's move on to the code here. So now in this code we are computing the average word to vec for each review in the pre-processed essay. So for that, first we are initializing the average word to vec vectors, where we are going to storing each of these vectors for each review. And now for each sentence in the pre-processed essay, we are initializing the vector of length 300 here, because we want the word embedding, or we want the vector of length 300 for each word. Okay, and also we are initializing the number of words for each row. And now you can see that for each word in the sentence, we are finding whether this word is present in the globe words that we initialized here or not. If yes, then we are getting the vector of size 300 and we are storing it in a variable vector here. And also we are keep on increasing the count by 1. So let me show you here with an example that what we are basically doing in this code. So for example, we are having the first row in the pre-processed essay that contains the word W1, W2 and W3. Fine. So with the first for loop, we are moving each row one by one, and for the second for loop, we are moving each word in the sentence one by one, right? So when we enter this for loop first time, that means we are at the first row, or you can say the first sentence in the pre-processed essay. And also when we entered in the second for loop first time, then we are at the first word of the sentence, that is W1 here. Clear? So now we are finding whether this word, that is W1, is present in the globe word or not. If yes, then we are getting a dense vector. We are getting a dense vector of length 300 for a word W1. And after that we switch to the next word, that is W2. And here also we are checking whether this word is present in the globe word or not. If yes, then here also we are getting a vector, a dense vector of length 300. And the same for the W3 as well, that here also we are getting a word embedding of length 300 for the particular word here, that is W3. So now once we get all the vector of length 300 for all the different words, now we just keep on adding these vectors so as to get a final vector of size 300, a final dense vector of size 300, that is representing by a variable vector that you can see here. So where this addition symbol you can see, with this add symbol we just keep on adding the vector for the different word so as to get a final vector of size 300. So irrespective of the number of words in each row, we will get always a final vector of size 300 in the end. Clear? So now also we just keep on increasing the count for the words in a particular row. So in this case we are having the 3 words. So the value for this variable for the first row is 3. So now in the end you can see, now we are dividing this final vector with the number 3 in our case, so as to get a average word to vec for the first row. So just like what we did for the first row, we have to perform the same thing for the rest of the rows. So that's why we just keep on appending the final vector on the variable average word-to-vec vectors that we initialized here. Clear? So now you can see the length of the average word-to-vec vectors that we are having the 5000 rows, and also you can see the length for the first row here. That means we are having a vector of size 300. Alright? So now let's see the another method. So the another method we are applying, that is TF-IDF weighted word-to-vec. So for that, first we have to calculate the TF-IDF value for a word and also the word embedding for that particular word. So in this code, we are first initializing the TF-IDF vectorizer here, and we are fitting it on the variable preprocessed_s. And now we are here creating a dictionary that contains the word as a key and the TF-IDF as a value. So you can see here, for example, that for each unique word in the preprocessed essay, we are now converting it to in a dictionary, so that we are representing each unique word as a key and the corresponding TF-IDF as a value. So you can see here, now in a dictionary we have all the unique words as a key value and with having their corresponding TF-IDF value. Fine. So now let's move on to this code here. So in this code we are computing the TF-IDF weighted word-to-vec. So this is the same code that you saw previously with some difference, that here we are finding whether the word is present in the globe words or not, as well as whether the word is present in the TF-IDF word or not, that we initialized here. That means in this dictionary. If yes, then we will get the vector of that word, that is of length 300, and also we are getting the TF-IDF value for that word. For example, if the word is W1, then we are getting this TF-IDF value for this word. Fine. And now for calculating the vector of that word, we are multiplying it. We are doing the multiplication with a vector of length 300 with its TF-IDF value, so as to get a final vector of size 300 for that particular word. And also here we just keep on adding the vectors for the different word, so as to get a final vector of size 300 for the first row, or you can say for each row. And here also we just dividing it in the final vector with the number of words in a first row, with the number of words in a row. Fine. And we just keep on appending the same thing, and we just keep on doing the same thing for the rest of the row, and we just keep on appending the vector on the variable TF-IDF weighted word-to-vec that we initialized here. Fine. So here also you can understand the meaning of each of these lines by looking into the description that we provided here. Okay. So now you can see the length of the TF-IDF weighted word-to-vec here also, that we are having the 5000 rows, and the length for the first row as well, that is of size 300. Okay. So now let's see how to vectorize the categorical features. So for that we have to first initialize the count vectorizer that you can see here, and within that we have to set the parameter binary is equal to 2. So with this parameter we are considering only the binary values for the word. That means if the word is present, we are replacing it with 1, otherwise 0. So now we are doing vectorizer.fit_transform and passing it to our categorical feature, that is school state. Fine. So now you can see the shape of the matrix after the one-hot encoding of the feature value school state, and you can see we are having the 5000 number of rows, and we are having 51 features of length 51. So you can see that for each row in the school state, now we are having a vector representation of size of length 51 starting from 0 till 50. And now for each row in the school state, we are having the value 1 for only one particular column, and rest of the values are filled with zeros. Fine. So just like what we did for school state, you will run the same code for another categorical features such as teacher prefix, subject categories and so on, and you will get finally one-hot encoding vectors for all your features, for all your categorical features. Fine. Okay.